Hello students, I am Dr. Vibha Srivastava from SRM3M Lucknow. Today I am discussed my 13th lecture of the measurement of force and pressure 1. Why I mentioned pressure 1 because we are the lecture number 31 is also dedicated to pressure. We are partial part of the pressure measurement. We can consider here measurement of pressure partial. Okay. So, we can discuss here now force measurement, how can measure the force and the pressure measurement till diaphragm gauge. Rest part is covered in the next lecture. First we discussed the basic concept of your force. So, as you know almost all students are aware about the force, but again I am telling because here you measure the force in industrial purpose or in the commercial purpose or in domestic purpose. So, as you know the force is one of the major derived physical parameters. Sometimes we consider as a pressure measure then converted into force or force measure then converted into the pressure. But here we I am trying to separate measurement from the force and pressure. Okay. So, here we consider force is one of the major derived physical parameters having dimensions of mass, okay, length and time. When we consider the dimension of mass and length and time, that is your force. It is a vector quantity obvious when applied result in a change of momentum in a body. A change in I am saying this is a force, this is not force. When I change some position, so I am applying a force from this my hand. So, the position will be changed. So, this is your applied result in the change in momentum in a body. Basically, mechanical force are created due to the variation of stored potential energy resulting from a change in some physical dimension or by the rate of change of momentum of some physical. This position is that I am giving the pressure back side, this is going to the downside. So, this is dimension of time rate of change momentum of a mass. Force due to the linear motion, it will be linear motion, it will be thrust, it will be vibration force or it will be rotating. Here we are using the all time, we are using this one, this is a linear force. When I counting this one, that is a rotating force, this is the vibration, this that vibrating, we are using the vibrating force. So, we are different type of form of the form when using the in the motor or in the rotation force, that is sometimes known as the torque also. So, these are some basic point force per unit mass being accelerator. Some are using the acceleration, then we consider the force per unit mass being accelerated. The measurement of force in situation where a system of force acting is carried out either the direct measurement or in the elastic device or you can say in the indirect method. So, we can measure in both sides. So, measurement force can be achieved in the where is both achieved by the mechanical as well as electrical as well as sensor as well as transducer. So, as per application, as per my I am again repeating lot of time, definitions are depend on the situation, application definitions depend on the situations, applications and condition. So, here you can see the force achieved by the mechanical measurement, that is mechanical force, electrical measurement say the electrical force. So, we can consider these are the basic concept for the force. Now, how will man measure the force? The measurement for a lot of previous transfer discussed, they can also use for the measurement of the force. We almost cover the all type of transducer. Now, coming the part of the measurement with the help of that transducer. So, many transducers use in various parameters, they can measure pressure also, they can measure force also. So, here again you can see here the strain gauge transducer, there is a piezoelectric transducer, force measurement using pressure transducer, magneto-destructive transducer, other force measuring system. So, we can use as per application. If a load cell is measuring as the pressure, then we call the for pressure transducer. If we are measuring in the force, then we call that load cell is known as the load cell measure as the force. If we measure the weight with the help of the load cell, then we can say this is the weight measurement transducer. So, depending on the application, the basic principles and transducers are same, they are measured different quantities. So, here again the discuss is the strain gauge transducer, piezoelectric पहले भी discuss कर चुके हैं. Piezoelectric आपका transfer होता है force measurement using pressure, ye cover in the pressure transducer also. Here I am also covering the piezoelectric transducer. So strain gauge transducer, we are, this is a basic and general purpose transducer for measure the force. So you have seen this diagram also. This is the load cell in the constructive form. Generally you have seen in the bridge form, they are using in the arms, we can change them. This is the converted form. You can see the device, the load cell device. This is a load cell device. This is a strain gauge. Load cell you are using this is strain gauge. So you can measure force directly with the help of load cell, or you can use strain gauge for the measurement of the force. So this is the second device for the force sensor, we are using as a strain gauge. ठीक है. Then the force sensitive resistors, this is the single point, you can see that this is the single point, the multi point motor sensors, this is the multi point, here is the using the multi point. So these are the some FSRs which are using for the directly force sensors, strain gauge, load cell. In load cell they are inbuilt in the strain gauge. ठीक है. Different type of strain gauge we have discussed earlier in my lectures. So now consider the measurement of force by strain gauge. SG is your strain gauge. So before slides, this is the, you have seen in the metallic form, there is the direct one, you are using the, these are the metal wires, these are the, you can see the foil, not wire actual, this is the foils. Everyone has seen the, you have a SIM card, that is, there is the some coating, you have seen the line of the copper, there is a copper and there is some line that tracks. So they are the same, this is the metal wires, this is the wire, this is the polyimide film, this is a film and this is a metal pad, dark portion is metal pad, this is a single strain gauge. और अगर if we are using this type, तो ये हमारा क्या हो रहा है, the pressure is applied here, here, here. तो दो firm lines है, that is your original portion of the that strain, and the dotted line is the deformation. When we apply the tensile force, the position of the that firm lines will be changed. It may be this side, it will be this side. The same thing is in compressive strain gauge. Yeah, earlier we are discussed in the strain gauge slides also. There applies the pressure. So there is a change in the this side. The dotted line is your change in deformation, and firm line is your. So we can use here, you increase the resistance. When you apply this type of force, tensile force, you can increase the resistance. When you compress the force, apply the compressed force, there is a decrease the resistance. So these are the basic concepts for measuring the strain gauge. Thus you can see the industrial application, we are using the, this is the bridge form. So this is also when you are using this is single, this is a single strain gauge. This single strain gauge, here you can use 1, there is a 2, there is a 3, there is a 4, but here you can see the as a values. Here I am mentioning the values हैं, and then this mention the direct picture is also here. This is the strain gauge and this is the your display device which are measuring the that force indirectly. We all parameter resistance we can change in resistance, that changing resistance calculate or calibrate in terms of that force. So we can measure with this help. So according to this diagram, transducer generally contains 4 SGs. ठीक है, क्योंकि we are using as a bridge formation. तो generally in bridge में we have a 4 arms. Weight instrument bridge अगर आप याद करेंगे तो they are always when you are using resistance or you are using strain gauge, in depend on different kind of capacitance or inductance, but there is using the weight instrument bridge में there is a 4 arms. So in 4 arms we are using the strain gauge. तो जो strain gauge changes as I mentioned above, जैसे ये पोजीशन चेंज होगी या तो टेंसाइल फॉर्म में होगी या फिर हमारे कंप्रेसिव फॉर्म में होगी, तो उसके हिसाब से जो हमारा चेंज होगा उसको हम कन्वर्ट कर देते हैं फोर्स में. तो ये हमारा क्या हो जाता है, फोर्स ट्रांसड्यूसर. इस तरह से हमारा क्या होता है कि फोर्स वर्क करता है और हम उस फोर्स जो हम मेजरमेंट करना होता है उसको हम कैलिब्रेट कर देते हैं डायरेक्टली इन द डिस्प्ले डिवाइस इन द फॉर्म ऑफ force. So these are the basic principles. Generally maximum use for the force measurement is strain gauge. Sometimes they are using heavy duty piezoelectric. So now coming to the force measurement by pressure. So in our before slides we have discussed about the force measure with the help of strain gauge. Now consider the with the pressure. So that is the for heavy duty. Here we have taken here 2 type. One is hydraulic load cell, another is load cell. And before we can say the strain gauge load cell. Here is the electrical load cell, this is the hydraulic load cell, and second one is the pneumatic load cell. For heavy duty, here you can see this is the loading surface where you apply pressure or as per the application. This is the pressure output and this is the hydraulic fluid. So, this is the simple diagram where it applies the pressure. We can change the position of this fluid. We are using the some mechanical parts also, so they can change the position. So, uske accordingly we can create the pressure and that pressure is converted into force. This we are, by you saying the hydraulic load cell, we are considering as the hydraulic. Now coming to the pneumatic load cell, then the pneumatic load cell is before we in the measurement of the motion we have discussed about the flapper nozzle system. The same thing, any pneumatic system when I have load cell as a motion measurement, as a pressure measurement, as a force measurement, as a weight measurement, where anywhere we are using if pneumatic word, that where you consider as a flapper nozzle. So, here again same principle, there is the nozzle or there is the some flapper, when we change the position of flapper up and down, the pressure will be changed. So, according to that pressure will be in form of pressure, in form of weight. So, we can calculate in terms of the force. So, we can here you can say the this value, this is the supply, there is a air supply, there is a ये तो पूरा आपका ये इसके अंदर air ही है, तो उससे लेते हैं, they are producing as a weight, यहाँ पे we can put in the weight. तो जब weight रखेंगे तो that position of nozzle will be changed, flapper and nozzle position will be, gap between flapper and nozzle will be changed. So, when will be changed, the parameter or metering value is also changed, that can be measured indirectly if you are in the cell. So, as per application for heavy duty we are using the hydraulic load cell, for medium heavy duty we can use the pneumatic load cell. For measurement of force you can measure with the help of pressure also, but here we can consider with the help of that pressure we can measure in the force. Force measurement, this is the some new not using for general purpose, but that is at present scenario we are using this magnetostaction type also. There is a corresponding change in the length of the length produce a result of magnetization. So, we can consider there is a Hall effect. So, there is a different from here is the concept is same, there is also using Hall effect transducer we are considering as a magnetism. Here we will also for force measurement we can consider as the magnetization. The material should be magnetostatic nature. There is a limitation. There is a limitation that material is the have a property of the magnetostatic nature. This is not in a ceramic we can use now. We never use the woods or any other non-conductive material. We use material which have a magnetostatic in nature. So, this is the limitation of the this phenomena. So, this phenomena is known as the magnetostatic is applied on a magnetostatic material. The material is the constant here. There will be a proportional change in the magnetic state of the material. When it passes the current or some change some voltage or current, they can change the your magnetic state. So, this property is first discovered the joules. So, this phenomena is the Joule effect. Everyone is Joule. I am not considering here the Joule effect. I am considering here the reverse process is called. This is known as Villari effect or magnetostatic effect. So, this is work of the Villari effect. What is Villari? So, this effect explains the change in magnetization of a material due to the force applied. Due to the force applied, वहाँ पे हम क्या कर रहे थे, when Hall effect में we produce an current or some power, then we change the magnetism. Here we apply the force. The Villari effects of magnetism is saying this will explain the change in magnetization of a material due to the force applied. So, this is this is Villari effect applied in the magnetostatic sense that this magnetostatic transfer is a device that uses the mechanical energy into magnetic energy or your magnetic energy into mechanical energy. This is the vice versa. Almost is the Hall effect. If you recall the Hall effect, that is the almost not using for force measurement, but here we are considered as a force measurement. So, this is the main property we can the Villari effect. तो ये हमारा है, this is not new, but this is a reverse process of Joule effect. Everyone knows about the Joule effect. So, इस तरह से we can measure the force with the help of the magnetostaction methods. So, these are some new not here about because this is the using sometime where the condition is magnetization, then we using this type of force measurement. And the next is your force by vibrating element. Sometimes they are using the motors or some vibration sensors, or there is a rotor, then how can we measure that force at that time? That time we consider as the resonance, that time we consider as the resonance. This important is the use in the force transfer of the vibrating element. If a tuning fork load cell is used, here you can see the strain gauge load cell, we have discussed the hydraulic load cell for the measurement of force, and here we consider the tuning fork load cell. So, the tuning fork hota hai, when you are using this to vibrate in the have two parallel band split connected, the both ends will be made to the vibration in the opposite direction. जब ट्यूनिंग फोर्स में हम उसमें करते हैं तो एक इस तरफ लगता है और एक इस तरफ लगता है, दैट इज नोन एज द दिस इज कंडीशन इज द अपोजिट डायरेक्शन. द चेंज इन रेजोनेंस दस कॉज विल बी द प्रोपोर्शनल द फोर्स अप्लाइड. जो उसमें जो आपका चेंज रेजोनेंस हो रहा है वो किसके अकॉर्डिंग हो रहा है, जो हमने फोर्स अप्लाई किया है. वह ट्यूनिंग फोर्क याद होगा, द ट्यूनिंग फोर्क देन यू सी द वाइब्रेशन बोथ साइड, दैट इज सेइंग हम दिस जो अप्लाई करेंगे उसी के अकॉर्डिंग हमारा जो रेजोनेंस है वो चेंज होगा. उस कॉन्सेप्ट पे लेके हमने इसको बनाया है. ट्रांसमिशन रिसेप्शन टू द पीजोइलेक्ट्रिक एलिमेंट्स गेट वेरी क्लोज टू द फोक, तो हम उसके आसपास में क्या रख देते हैं, वी कैन कंसिडरेशन एज अ पीजोइलेक्ट्रिक. तो ये हमारा एक मेथड है, वहाँ पे मेजरमेंट करना होता है जहाँ पे हमारा वाइब्रेशन होते हैं या वाइब्रेटिंग डिवाइस होती है या कोई वाइब्रेटिंग एलिमेंट होती है. तो इस तरह से हम फोर्स को मेजर करते हैं विद द हेल्प ऑफ डिफरेंट ट्रांसफर एज पर कंडीशन एज पर एप्लीकेशन. नाउ कमिंग टू द वेरी इंपॉर्टेंट पैरामीटर and this is used for the industrial purpose as also domestic purpose also and for the daily use purpose also. So, the pressure, now coming to the move to the motion, we discussed in previous lecture, we are discussing the motion measurement. Now, here we discuss in previous slide we discussed the force measurement. If you seen from all measurement, for motion measurement, vibration measurement, pressure, again flow and temperature, they are both are the similar, all of the some similar using the some similar transducers. Here again the very important parameter for industrial purpose also, or you can say the industrial parameter, this is the pressure measurement with the help of pressure transducer, or you can say the indirect we are using the pressure transducer for the measurement of pressure. So, before moving to the transducer part, we can discuss about the basic concept of the pressure. Why I am discussing pressure? Because pressure is a lot of different type of pressure we are using. We are using vacuum pressure, we are using atmospheric pressure, we are using gauge pressure, we are using a total pressure, we are using absolute pressure. So, first we discuss about the what type of pressure we are using, but in general purpose we are using is the gauge pressure. If industry point of view, we always measure in the gauge pressure. So, this is you have seen here the thing here. So, pressure is the force per unit area. There is no need of explain the definition of force pressure, but we move to the different type of pressure. The first we consider as the atmospheric pressure. So, in an atmosphere I am standing here, there is a using as the atmospheric pressure due to the air surrounding the earth's surface is called the atmospheric. I am standing in this room, you are standing there, or you are standing you are sitting somewhere, you are feeling there some atmospheric pressure. So, this is the common pressure, but coming to the in the absolute pressure, this is the known pressure is 4 per unit, this is important, this is for unit area when the interaction of the fluid particles among themselves is 0. A 0 pressure is in interaction intensity will be occur. This is the possible only when the population of the molecules is negligible or very small that time. So, this is which means the perfect vacuum. Okay. So, this is the your absolute आगे की स्लाइड में आपको दिखाएंगे, थोड़ा ग्राफिकल दिखाएंगे. तो so this is the definition. So, the perfect vacuum, hence the pressure intensity measured from a state of perfect vacuum is called a absolute pressure. This is the definition. So, it is equal to the gauge pressure plus atmospheric pressure. तो absolute pressure हमारा क्या होता है, that is your gauge pressure. अभी आगे हम करेंगे, अगर PG उसको डिनोट कर लेंगे, अलग उसमें दिया है, and then use of the PAT. तो ये जो हमारा क्या हो जाएगा, that is known as your absolute pressure. ये रिक्वायरमेंट पड़ती है हमें एज पर एप्लीकेशन के साथ. नाउ कमिंग द गेज प्रेशर, यू हैव सीन हियर पहले जस्ट डिफिनेशन. Pressure measuring instrument generally measure the difference between the unknown pressure and the atmospheric pressure, sometimes known as the differential pressure also. When the known pressure is greater than the atmospheric pressure, the pressure measured by instrument is called the gauge pressure. Condition again is very important, when the unknown pressure is greater than the atmospheric pressure. That condition is if fulfilled, that is known as the gauge pressure. In gauge pressure zero reference in upper side, that is known as the your positive, in the negative side we can use the negative pressure. We can discuss here again. Then move to the vacuum pressure. A pressure measuring instrument generally measures the difference between unknown pressure and the atmospheric pressure. When the atmospheric pressure is greater than the unknown pressure, the pressure measured by the Colbeck greater than the unknown pressure. यहाँ पे क्या था, greater than the atmosphere. Please confuse मत होइएगा. There is some important word. There is using the greater than atmospheric pressure. ठीक है. और यहाँ पे हम क्या कर रहे हैं, ग्रेटर देन द अननोन प्रेशर. जो हमारा अननोन प्रेशर है वो ज़्यादा होगा, और वहाँ पे क्या है, गेज प्रेशर में एटमॉस्फेरिक प्रेशर ज़्यादा होगा. अगर आप इसको यहाँ पे देखेंगे तो और अच्छे से समझेंगे. दिस इज द पॉइंट ए, ठीक है. वेयर वी कंसीडर एटमॉस्फेरिक, ये हमारा क्या ऊपर की लाइन एटमॉस्फेरिक है. ये हमारा क्या है, एब्सोल्यूट प्रेशर. तो पी ए बी सी इज एब्सोल्यूट प्रेशर, ठीक है. दिस इज योर एब्सोल्यूट प्रेशर. यू कैन कंसीडर पी जी प्लस पी ए टी एम, दैट इज योर एटमॉस्फेरिक प्रेशर, ठीक है. इसी तरह से हमारा इसमें भी एटमॉस्फेरिक प्रेशर पी वी एस सी पॉइंट, ये पॉइंट बी है, ये पॉइंट ए है ऊपर ले रहे हैं, ये हमारा क्या है, पॉइंट बी है. तो जो इस यहाँ पे इसके नीचे है, वी कैन क्या होता है, वैक्यूम प्रेशर. इसके ऊपर हमारा क्या है, गेज प्रेशर. इसके नीचे हमारा क्या है, एब्सोल्यूट वैक्यूम प्रेशर. इस तरह से हम ये देखेंगे कि एब्सोल्यूट प्रेशर, एटमॉस्फेरिक प्रेशर एंड आपका वैक्यूम प्रेशर, इस तरह से हम इसको मेजर करते हैं. एब्सोल्यूट वैक्यूम्स ये डिपेंड करती है जैसी हमारी रिक्वायरमेंट होती है, बट जनरल पर्पस वी मेजर द गेज प्रेशर पीजी, दैट इज नोन एज द गेज. दीज आर द सम प्रेशर्स. अब ना हाउ कैन मेजर द प्रेशर, मेजरमेंट कैसे करेंगे, विथ टाइप, क्योंकि यू हैव सीन द लॉट डिफरेंट टाइप ऑफ प्रेशर. तो हमारे पास जो प्रेशर मेजरमेंट डिफरेंट टाइप का है, रिक्वायरमेंट डिफरेंट टाइप के, तो ऑब्वियसली हमारे इंस्ट्रूमेंट भी डिफरेंट होंगे, हमारा सेंसर भी डिफरेंट होगा, हमारा ट्रांसड्यूसर भी डिफरेंट होगा. तो दिस कॉन्सेप्ट इज गिवन फ्रॉम हियर. तो वी मेजर द वांट टू मेजर द लो प्रेशर, वी ब्लाइंडली यूजिंग द जनरल पर्पस इंस्ट्रूमेंट दैट इज नोन एज मैनोमीटर, एवं यूट्यूब मैनोमीटर, ठीक है. हाई एंड मीडियम प्रेशर वी आर यूजिंग द बोर्डन ट्यूब प्रेशर गेज, डायफ्राम गेज, बेलोज गेज. रिमेंबर वन थिंग, द मेन थिंग इज द कॉन्सेप्ट इज बोर्डन, diaphragm and below. Baki they are using for the high and medium pressure measurement. And now again come to the vacuum measurement या ultra high vacuum, very 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 low pressure, 10 to the minus 6 torr, 10 to the minus 3 torr. That time was a special purpose measurement, pressure measurement instrument known as McLeod vacuum gauge, thermal conductive gauge. Thermal conductive is divided into two parts, one is Pirani gauge, another is thermal conduction gauge. I will discuss in next slide. So you can see the in the ionization gauge. These are used for the vacuum measurement or in the gas measurement. तो एज पर एप्लीकेशन हमारे प्रेशर मेजरमेंट करने के इंस्ट्रूमेंट अलग अलग हैं. तो फर्स्ट वी डिस्कस इन शॉर्ट फॉर्म इन द मैनोमीटर. दिस इज द जनरल पर्पस मेजरमेंट फॉर द लो प्रेशर और यू कैन से द लो मीडियम प्रेशर. तो वी कैन कंसिडर दैट टाइम वी मेजर द manometers, where we consider inclined manometer, different type of manometers. Today we are using the digital manometers, but here we discuss only the basic concept of the manometers, U-tube manometer. So we consider the construction. One time is the there is a difference between, suppose this is a PA, P unknown, or you can see the PA. So the difference between this and this is they हम क्या करते हैं, we consider as the height और दोनों का difference लेते हैं with density and gravity. Then you can measure directly measure the pressure with the help of the manometer. This is a simple U-tube manometer and very easy. We are using for the liquid this manometer, it may be water or mercury. Here we consider the measurement, where we consider positive pressure, where you have the increase this one and this is decrease. और ये हमारा where discussed about previous lecture, we have as the negative, this is the up and this is the down. तो ये हमारा क्या हो गया, negative. और this is the in between the difference जो हम ले रहे हैं, this is known as gauge pressure, because this one and this one, here is this one and this one. अब diagram से you can understand, there is no need of different, we have discussed about that thing also, but there is the gauge pressure. The difference between these two, this is known as a gauge pressure. So we can measure with the help of manometer directly to the gauge pressure. Now consider the how. Again the pressure extracted by the column of fluid is height h. तो जो हमारी क्या है, ये हमारी h है, यहाँ पे यू कैन कंसिडर एज द h, डिफरेंस बिटवीन दैट. Density of is equal to given the hydrostatic pressure equation, P is equal to h rho g, that is your, this is the gravitational force, this is the height of the column. तो ये हम डायरेक्ट मेजर कर सकते हैं हाइड्रोस्टेटिक. अगेन द प्रेशर डिफरेंस बिटवीन द अप्लाइड प्रेशर, अगर इसकी बात करेंगे तो फिर हमारा क्या हो जाए, पी ए माइनस पी जीरो. वन इज द एटमॉस्फेरिक प्रेशर एंड अदर इज हमारा मेजरमेंट. अगर हम यहाँ पे करेंगे तो दिस इज योर पी ए, हियर इज अ पी ए. कंडीशन अलग अलग है इसमें वो में, तो दिस पी ए माइनस पी जीरो एच जी रो. In other words, if the liquid is static, movement नहीं है, the pressure on either end of the liquid shown the P is equal to P0 H0. तो इस तरह से we can measure directly the dense hydrostatic correction in pressure measuring desired. We can direct measure the pressure with the help of this. Again, this is the very important parameter. We are using the Bourdon tube pressure gauge. So Bourdon tube pressure gauge is the general way you have seen in the your home and in your colleges, offices, any lines, pipelines, water lines, gas lines. They are using they are using Bourdon tube, C type Bourdon tube. So there is the construction. You can see this is the external. You can have seen this is the indicators. यहाँ से we can apply that pressure. जो मेजरमेंट करना है, ये हमारा इंटरनल कंस्ट्रक्शन है, ये हमारा रैक एंड पिनियन होता है, इंडिकेटर होता है, सी शेप बॉर्डन ट्यूब होती है, पूरा कंस्ट्रक्शन होता है. तो सी शेप बॉर्डन ट्यूब होती है. तो यहाँ पे जब हम नीचे से अप्लाई करते हैं तो इसका शेप क्या होता है, डिफॉर्म होता है. जब उसके प्रेशर अंदर डालेंगे तो जो ऊपर जो हमारा लगा होता है रैक एंड पिनियन, इसमें मूवमेंट होता है. इससे हमारा क्या जोड़ा होता है, इंडिकेशन. जो प्रेशर होता है वो डायरेक्टली आप इसमें देखते हैं. तो ये तो इसका बेसिक कंस्ट्रक्शन है. अगर इसमें सबसे इंपॉर्टेंट है कि मटेरियल कौन सा कहाँ पे लगाएंगे. तो गेज मटेरियल, गेज डायमीटर, प्रेशर रेंज, किस प्रेशर रेंज, भाई हर एक ही प्रेशर रेंज पे हम सारे गेज नहीं लगा सकते, क्योंकि जो हमारा बॉर्डन ट्यूब गेज है, ये बॉर्डन गेज हमारा है, ये हमारा हाई लो से मीडियम टू हाई है. तो एक ही उसमें टेम्परेचर पैरामीटर्स में इफेक्ट करते हैं. प्रेशर रेंज अलग अलग होती है. जिस रेंज का मेजरमेंट करना है वो हमें प्रेशर गेज लेना है. ऑयल में करना है तो ऑयल प्रेशर गेज आएगा. आपका किसी लिक्विड में करना है तो लिक्विड वाला अलग आएगा. तो सबका उसका मटेरियल अलग होगा, इसलिए हमने पूरा डिटेल. गेज मटेरियल इज़ वेरी इंपॉर्टेंट. गेज डायमीटर उसका कैसे कितना है, भाई अलग अलग साइज़ का है, अलग उसके लो है तो लो, मीडियम है, हाई है. अब 400 kg पर सेंटीमीटर उसका मेजर करना है या PSI में मेजर करना है. इसकी यूनिट एक्चुअल में हम पास्कल या PSI में लेते हैं. तो दिस डिपेंड अपॉन अब टेम्परेचर रेंज वहाँ पे भी हमें है, तो वहाँ पे भी मेजर करना है प्रेशर में. उस टेम्परेचर का हमें प्रेशर भी मेजर करना है. तो दैट टाइम यूजिंग द टेम्परेचर रेंज. तो वी कैन कंसिडर व्हेन वी कंसिडर द सिलेक्शन क्राइटेरिया इज वेरी इंपॉर्टेंट फॉर द Bourdon tubes. In YouTube manometer there is no limitation on material. We are using the simple glass tube and using the only two type of material, mostly mercury or water. But here with the application is different. Sometimes using in the gas, sometimes using slurries, sometimes using the direct pressure, sometimes using the high pressure. So we can, this is the these are the material selection criteria in the, especially in the Bourdon tube gauge. So there is the corrosion resistance, mounting options, पैरेलल माउंटिंग है, बेंडिंग माउंटिंग है, स्ट्रेट माउंटिंग है. तो ये सब कितना भाई सबसे इंपॉर्टेंट है कि व्हाट इज़ द रेंज, कितना उसका पास्कल है, बार में है, वो तो अलग चीज़ है. बट इन मीडियम हाई, मीडियम तो हाई रेंज मतलब 400 kg पर सेंटीमीटर स्क्वायर, 600 पास्कल. यू हैव सीन द देयर इज अ 10,000 PSI, 8 to 10,000 PSI. तो हम सेम प्रेशर गेज वी कांट यूज इट, बट दिस इज द हाई रेंज. वी कैन मेजर द एप्लीकेशन वी आर यूजिंग एवरीवेयर. You have seen the in chemical processing plant, agriculture, automotive, marine, power supply, HVAC, aerospace में this is the general purpose pressure measurement. कॉस्ट बहुत कम होती है और बड़ा यूज़फुल है. तो ये हमारा इसमें अगर हम यूज़ करेंगे सेम वैसे ही है. वहाँ पे हमने सी बॉर्डन ट्यूब लिया था, यहाँ पे देखेंगे तो वी कैन कंसिडर एज द डायाफ्राम. मैंने कंसिडर इसका मटेरियल हम क्या कर देते हैं, इसका प्रेशर रेंज चेंज हो जाएगा. तो डायाफ्राम अगर हम यूज़ करते हैं तो हमारा क्या कहलाता है, डायाफ्राम प्रेशर गेज कहलाता है. तो इसके देखेंगे तो एडवांटेज आप देख रहे हैं, लोड परफॉर्मेंस है, लिनियरिटी है, फिर भी ठीक है. सिस्मिक के लिए यूज़ करते हैं. दिस इज़ द, यू कैन सी द दिस इज शेप ऑफ द डायाफ्राम. ये हमारा इस तरह से, बस बाकी सेम वैसे ही होता है. वी आर यूजिंग द शी शेप्ड, और ये हमारा क्या है, ये डायाफ्राम. डिफरेंट एज पर एप्लीकेशन. तो दीज आर आवर जस्ट मेजर द डायाफ्राम गेज. ओके, थैंक यू.